Hello my dear students, I am B S Pandey, your physics lecturer. Today we are in lecture number 28 of standard 11. Student, we have solved few questions in last lecture. We have studied and learned how to tackle the questions that are based on Newton's second law. Today we will solve few more questions, basically the Pulley mass system, and then we will come to the question that are based on relative acceleration. Okay, so look at here the first question that we start today's lecture. It is lecture number 28. Lecture 28, Newton laws of motion. We are studying. It is the chapter number 5 of NCERT. Alright, so the first question let me discuss from NCERT only. Okay, it is given in NCERT the two cases. Here a man is standing at certain frame and trying to pull a block or the bucket, you can say, of mass m. Here the mass of the man, it is m. Alright, yes, this is the first case. Here the mass of this block, it is given 25 kg, and the mass of this person, it is given 50 kg. Now in second case, his clever brother is pulling the same mass, but he is using a pulley mass system to pull the same bucket from same depth, and all are identical. Okay, yes. Now the question is, again, here the mass of this man, again 50 kg, and this is 25 kg standing on the surface, but here he is using pulley. This floor can withstand with 700 Newton maximum force. 700 Newton. More than 700 Newton force will cause the breaking of this floor, and of course you can understand what will happen with the man. Which one is the correct way to pull the block, whether in this way or in this way? This is our question. Okay, so let me solve. How to solve this question? Here we have to make the free body diagram. Of course this weight mg, it is not going somewhere else, but it is transferred to the hand of man and going to act on the floor. If it is T, the system is in equilibrium. Here the mg, and this is the tension T. Here you can see the tension, it will be T in upward direction. The weight of the man, it is capital Mg. Here the weight of the man, it is capital Mg again. Here the normal reaction will be N. Here the normal reaction will be N1, and suppose it is N2. Remember, N1 and N2 are the forces acting by flow, or you can say the flow will act the force the same as it will experience. If this N1 or N2, if this N1 is greater than 700, remember, if it is greater than 700, then this flow will break off. If this is greater than 700 and 2 is greater than 700, then again this flow will break off. We are going to find which one is correct method to pull this block, or both are not incorrect, or both are correct. Okay, so let me solve. Here you can say the total force acting for this system, and here for this system we have the free body diagram for this case 1, and this will be the case 2. So for case 1 we can write here N1, it is in upward direction, it equals to T plus mg. Alright, and here T can be written as mg, sorry, the small m, mg. It means N1 it is mg plus mg. It is m plus m, that is 50 plus 25 times g, suppose it is 10, then it is 750 Newton. It is n dash, and this n dash N1 is greater than 700 Newton, so this floor will collapse and this particular person will go down. Now here in second case, case 2, try to understand. The second case I am going to plot over here. For man, you can see the two forces acting in upward direction. It is N2 plus T, which is equals to mg. Again from this block you can see the T equals to mg. T is equals to mg small m times g. So you can write the N2 is equals to mg minus small mg. It is 50 minus 25 times g. It is 250 Newton N2. You can see the smile on the face of this man. Yes, this is the right way to pull the block from this well, you can say. My dear students, you might have noticed in village area, pulleys are provided over the well to pull the water from inside. It is to reduce the work of that man. Why? The man is doing less work, that's why applying the less force. Alright. And if you will connect more than one pulley, the force will be much lesser. So this pulley is very helpful. By the way, this was the question of NCERT we have solved. Now, the next question we are going to solve. Then after we will solve few question of relative acceleration, which is aim of today's lecture, my dear students. The next question, it is now, this is the pulley. And the two blocks are given. It is M and 2M. We will learn today the shortcut method to find the acceleration of such type of system and tension. And you can also find the net force acting on the ceiling as well. Okay. What is the question here? M, it is suppose 10 kg. Then you have to find acceleration. You have to find tension. And you have to find force on ceiling. Okay. Okay. Now let we solve this question. The tension, the weight twice mg. Here the mg, you can write the tension T. Here you can break the tension as T dash. Now for each, suppose the system is moving down with an acceleration A, of course it will goes up with an acceleration A. We can put the positive axis as x and y in this direction. The system is going down, it means this one is the greater force, so we will write this 2 mg minus the lesser one is the T trying to stop this one, and this one is trying to move this body, so the force which is trying to move minus the force which one is trying to stop that body must be equal to m times a, and here the m is twice ma. Now for this body we can write here which one is pulling this body up, it is T. So T minus which one is trying to stop the body, it is mg. So minus mg equals to m times a. You can sum up to get the net value. It is T will be cancelled out. It is mg is equals to twice ma. You can have the acceleration here, m will be cancelled out, so it is g by 3. Okay. Now shortcut, my dear students, you can have the net force, it is sigma f is equals to ma, and this will be also the sigma. So this is the second method, the shortcut method I am telling you. How you will find the result here using this two block, because this two block is only responsible to move the system, and for this system which one is trying to move this system, it is twice mg down, and which one is pulling up, it is the mg. Despite of this mg it is moving up, so this will be considered as up. Now the net force, it is twice mg minus mg, it is how much, mg, and this net force is moving the total amount of mass, how much, it is m plus 2m, it is 3m. So 3ma. This will be directly, you will get the answer g by 3. You can see the same result. So you can write directly this one also. Putting the value of a, you can have the tension as well for this question. I hope you understand. This shortcut you will apply in few more questions I'm giving you, and then you will feel confidence. In too many questions you can apply this shortcut to get the answers directly. Okay. Now the next question. So the next question is, if you can solve, you must pause the video after noting down the question and try to solve by yourself using both the method, the shortcut as well the complete method. Here the m, suppose 2m, the system is moving down with an acceleration a. If m is 10 kg, then you have to find acceleration, tension in each string. Okay, acceleration and tension in each string. Yes, what will be the answer? Try to solve this question, pause the video and try to solve this question. Okay, now let me solve this question. Here the tension T1, T2, the weight, it is mg down. Here the weight, the twice mg, here the weight mg, and the normal reaction n. Now you can see the total force which is acting to move the system in along the y-axis, it is twice mg and this mg. Remember, due to this mg, the system is not moving up and down. Remember, this entire value are moving up and down, but this mg is not moving, okay, at all. So here the twice mg down, here the twice mg up. The net force will be how much? It is twice mg minus mg, it is mg, equals to total mass into acceleration. How much total mass? m and twice m. It is 4m into a. So it is g by 4. Now my dear student, you need to solve this question properly with the complete method, you will find the same answer. Once you will get the acceleration, you can find the tension in each string as well. If you have been asked to find the acceleration only, then you can see how much this save you time. This is the first method. Now, my dear students, you can find out the acceleration tension in each string by using this acceleration as, for example, look at here, the T1, the system is moving up, the T1 minus mg, it is equals to ma, this is ma and it is g by 4, alright. So it is T1, you can write here, the mg by 4 plus mg. You can see this is also become the faster for calculation, and it is 5 by 4 mg. For this one, you can find out, for this one, it is the twice mg moving down minus T2, it is twice ma, and a is g by 4, that is mg by 2. So the T2 equals to twice mg minus mg by 2, it is 3 by 2 mg. Okay, so you can see how much you are saving your time. Now, for this block, you don't have to do any equation. Already you have been calculated the tension, remember. Okay, so you don't have to write for this equation. If you need to find the normal, then you can write the n is equals to mg. It doesn't matter how fast this body is moving, all right, the normal will not change, because this normal, it is on the y-axis. Now, let me solve few more questions. Okay, last question, my dear students, I'm going to solve. Then after I'll give you the questions, I will solve here the question for the relative acceleration. Here the homework, and then after one more question I will solve, my dear students. Okay. M, 2m, m. If m is 10 kg, the first homework, then you have to find force on ceiling, acceleration of the system, and tension in each string. Okay, the second question. Using the shortcut method, could you write the equation for this one also? Try to do at your home. Alright, again m is 10 kg. You have to find acceleration of the system, you have to find tension in each string. Here you have to find acceleration, tension in each string. Alright, so there's two questions. One more question I'm going to solve, and then after we will move for the relative acceleration questions. m 3m, it is 53 degrees. Alright, and the question, you have to find acceleration and tension in each string if m is 10 kg. M, I'm giving you here the 10 kg. What you have to find? Acceleration of the system, tension in each string. If you can solve, pause the video and try to solve this question. Stop the video for a few seconds and try to write the equation. At least you can compare the result what I'll get. Okay, so pause the video and try to write the equation. Now let me solve this question. This is the inclined one, plus mg normal and 1. Here the mg, remember, don't use here the normal because this body is not kept on the surface, but it is kept on the surface. It is kept on the surface. All right, here the tensions. T1 tension will change because the string change. T2, it is T2. All right, here the thrice mg, and this is theta, so this will be 3 mg cos theta, and this will be the 3 mg sine theta. You can write this is at N2, not more forces we are having. Now we are going to write the equation. Suppose the system is moving in this direction with an acceleration a. Of course it will move up and it will move forward with the same acceleration because all the strings are straight and connected. Here we can write the equation T1 minus mg is equals to ma. My dear students, why I am solving this question? Because I am not getting very much homeworks from you all, my dear students. It means you all are having a little bit confusion while solving this type of question. Of course, very few students are solving this question. Out of that, also the few students are not getting proper concepts, but I am very happy that the few students are submitting their homework. Okay, that's why I am solving again and again such type of questions, so that you will be much crystal clear. Here it is T1 minus mg is equals to ma. For this one, for this body we can write, of course the system is moving in this direction. Which force is pulling this body in this direction? Of course it is T2. And which one is trying to stop this body in this direction? It is T1. So the greater force will be T2. So the T2 minus T1 is equals to ma. This is another equation. Okay, from this body. Now for this body, which force is trying to move this body downward? It is thrice mg sine theta. So it is thrice mg sine 53. And which one trying to stop this body? Of course it is T2. And is it equals to, okay, is equals to, despite of these two forces are acting, this body is moving downward with an acceleration a. That's why we write here the thrice m times a. My dear students, sum all the equation 1, 2 and 3. Here we have not written the number of equations, so the 2 and 3. What you will get? Here the T1 will be cancelled out, T2 will be cancelled out, and then you will have here the thrice mg sine 53, it is 4 by 5, alright, minus mg is equals to how much? It is the ma, and thrice ma, it is the 5 times ma will be m cancel out. Yes, then a can be written as the 4 times 3 it is. Let me solve over here. This was the homework. Let me drop this. Okay. Let me solve. Here the 12 by 5 minus, it is z, it is 10. It is 10 till 12, no, it is 120 I think. Yes, the 10 I am missing here is equals to 5 times a. So the a will be how much? It is 50 and it is 120. Directly we can write 70 by 5 times 5. It is a is equals to 70 by 25 meter per second square. Now my dear students, as you got this value, then acceleration 70 by 25 meter per second square, you can put this value in equation 1, 2, 3 to get the value of T1 and T2. I hope you are much clear. Okay, the same type of questions, my dear students, we will use to solve in friction chapter also. Okay, So those students are not getting properly, you will get another chance to understand this type of question in friction segment. Alright, let me wrap this one. And the last question I'm going to solve over here, and then I'll give you one homework which is based on relative acceleration. This is the very superior constant body problem, my dear students. This question actually mentioned in SC Burma. You can find this question as well there. This is the mass M going over a pulley, another pulley, and two masses are hanging over this pulley. Suppose it is going with an acceleration A1, it is going with an acceleration A2. Of course, it will move. With an acceleration A2. You have to find the acceleration A1, A2. A1 and A2. The values are given. It is M. It is twice M. Okay. Those pulleys are massless and frictionless. All the value you can write here. The M is equals to 10 kg. For simplicity, to solve the question. Okay. Now look at here. How you will solve this type of question, my dear students. In next class, I will discuss about the frame. Okay. The frame of reference. I am using here the concept actually. Okay. I was totally prepared to discuss this type of question without giving the concept of frame, so that you will understand and you will try to understand the frame in better way. Here, my dear students, look at here. As this body M will move with an acceleration A, these two bodies are moving independently with an acceleration A2. If it is moving down with an acceleration A2, it is moving up with an acceleration, same acceleration A2. But if this body is moving with an acceleration A1, what will happen? This pulley is not in static state. This pulley will move with an acceleration A1. It means the net acceleration for any observer, if any observer is standing over the ground. So for this particular observer, this system actually it is coming down, but this observer will not experience the acceleration of this block. It is only A2. It is moving with A2, but this pulley is also moving down. So the net acceleration will be sum up as A1 plus A2. So we'll use the net acceleration of this block as A1 plus A2, and this block, the acceleration, suppose this pulley is moving down, that is the entire system. Let me this entire system is moving with an acceleration A1 down, and if this body is moving with an acceleration A2, suppose if this A1 and A2 are equal, what will happen? This observer will feel this is not moving at all. Alright, yes, it is moving 2 meter up, but this pulley make this body 2 meter down. Overall, this is supposed to be in rest. That is the velocity, acceleration. If acceleration is 0, then you can say the velocity is constant. Okay. Now, we can solve this question by the two methods. One method, we can consider the net acceleration of this block as A1 plus A2, and this acceleration, the acceleration as A1 minus A2, and the other things are similar. But the another method I am telling you, my dear students, you have to use. Look at here carefully. Here, what will happen if we'll apply the same force? If the system is moving with the force of F, and we'll apply the net force in upward direction F, what will happen? The net force will be 0, and the body will have the acceleration as well 0. Then the system will move within a constant acceleration. Okay, so I'm going to solve this question by the second method, and this method, remember the first method you can apply here. The tension, let me write the values. Free body diagram, it is T1, T2, of course it will be the T2. So by the first method, you can write the equation. I'm writing in very short. Look at here. The T1 is equals to MA1. The first, for this body, you can write here the mg acting, here the twice mg acting. So for this body, of course, with an acceleration a1 plus a2, it is moving down. Then you can write the twice mg minus T2 is equals to m times a, and m it is the twice ma. So the twice m, and a will be how much? Now it is moving with an acceleration a1 plus a2, and the equation for this body we can write it is moving up. So T2 minus mg is equals to the acceleration, it is m times a1 minus a2. Okay, so this three equation, and this three equation will help you to find out the value a1 and a2, because in this three equation you are having only the variables and you have to find it. Now my dear students, this is the method, but what I am telling you to solve this question by giving the net force 0. If this entire system is moving down with an acceleration how much? A. So over this system the net force will be how much? In the opposite direction it will be the m times a. If you apply a force here ma, how much m? It is m, and with what acceleration this system was moving? a1, so m a1, and on this body it is ma, it is twice m, and with which acceleration it was moving? a1, so it is a1. In this case you can find the net force on this one as 0, the net force on this one as 0. For which observer? For this observer. Now it is moving inside this frame only. For this observer it is in rest. This system becomes in rest for this observer. For any observer inside this particular dotted system it is moving. So for that observer we can write the equation. Now it is moving with an acceleration a2 up and with an acceleration a2 down. So we can write the equation. For this one it is moving up, T2 minus the net forces which are acting downward. Here the net forces which is acting in upward, it is T2 plus m a1 minus mg is equals to mass times acceleration. So the m and acceleration with it moving, this is the first equation for this body. Now for this one we are going to write the equation. It is moving down with an acceleration with the force twice mg. And what are the forces in opposite direction? So T2 and twice m a1. So minus T2 minus twice m a1 is equals to mass times acceleration. It is twice m, and acceleration which is moving down, it is a2. So we can arrange this one. You will find these two equations are same. Okay, by arranging these two you will get this one and this one are very similar. Now my dear students, I have given you the equation. You have to simplify this equation to get the answer, that is the a1 and a2. All the values are given. I have given the mass of the block, it is 10 kg. So simplifying these three equations, and for this equation by this method it will remain same as this one. It is T1 minus m is equals to, because no force, it is in opposite direction, it is m a1. So the equation 1, equation 2, and this is the equation 3. Solving this three equation you will get the values of all the things that you have to find here, my dear students. Okay, so you have solved this question by the two method, either by stopping this frame or by using the relative acceleration. Okay, my dear students, here I am giving you a homework. Can you note down? And you will get the practice over such type of question. In my assignment you will get the number of question, at least 3 to 4 question, that you have to use the concept to solve the relative acceleration problems. Another homework I am giving you, my dear students. Yes, so it is pulley. It looks like that it is moving. M, 2M, and this is M. Okay, this system is moving with an acceleration A2. It is moving with A2, and this block is moving up with an acceleration A1. What you have to find? You have to find acceleration, tension in each string, force on ceiling, all the values. Okay, so this is the question. M you can take here 10 kg to get the exact answer. Okay, my dear student. So this is all about today's lecture, my dear students. You can take the values of A1, A2 also, and then you can find the tension. Okay, so this is all about today's lecture, my dear students. Thank you very much.